Hello everyone, welcome to my channel. So today I am going to solve problem on the Turing machine. So here the problem is design a Turing machine to accept the language 0 to the power of n, 1 to the power of n for n is greater or equal to 1. So according to the given language, the set of the strings belongs to the language is when n is equal to 1, the string is 0, 1. For the n is equal to 2, the string is 0, 0, 1, 1. Next is 3 zeros followed by 3 ones, so on. Now we need to design the Turing machine for this language. We know that in the Turing machine we are going to use a tape drive. Okay. So here I will take the string as 0, 0, 0, 1, 1, 1, and so let me take this string into the tape drive 0, 0, 0, 1, 1 and 1. And you know that the tape drive is an infinite sequence of symbols, and we have inserted the string into the tape drive, and remaining cells will be replaced with a blank space. Here I will take B for the blank space, and it is an infinite sequence. All these spaces will be replaced with a blank space. Now you know that initially in the tape drive the control 8 is pointing to the first symbol of the string. Okay, so here the control 8 is pointing to the first symbol of the string. Here the first symbol 0 is there. Okay, for this 0, for this language, what I will do, we can perform the two operations. Either I can read the symbol on the cell or I can update the symbol on the cell. Here 0 is there. Here I will update the symbol 0 with the X. Okay, so for the input symbol 0, I will replace that 0 with the X, and I will move to the position, so right side. You know that we can move to only the two direction, either left and the right, R for the right direction and L is for the left direction. Now here R is there. R means the control 8 will be pointing to the next position. So here the symbol 0 is there. Okay, here what I will do, I will retain this symbol as it is, because according to the language, the strings that should be accepted is 0, 1, 0, 0, 1, 1. According to this set of strings, we can observe that for 1, 0, we need to get one symbol. And for the next 0, we need to find out the next occurrence of the symbol 1. Okay, for one occurrence of 0, we need to find out the first occurrence of the 1. And for the next 0, we need to find out the next occurrence of the 1. Okay, so in order to get the first occurrence of the symbol 1, I will keep on moving the control head until I will get the symbol 1. Okay, so here since here 0 is there, this 0 I will retain as it is, and 0, and I will move to the right direction. And so I will not update, this will be retained as it is, and in the next, and then the control head move to the next position. So here also the symbol 0 is there. Okay, and then I will retain as it is. That can be achieved by using this transition. And again, since right is there, I will move to the next cell. So the control head is pointing to this cell. Now observe the cell. So the symbol 1 is there. So this indicates that we got the first occurrence of the symbol 1. So for this one, I will update with the symbol y. So 1 and y. Now what I will do, I will move to the left direction, because the method is for the first occurrence of the symbol 0, we need to find out the first occurrence of symbol 1. Now we need to find out the second occurrence of the symbol 0. So because of this reason, we need to move to the left direction. Now I move to the left direction. Now the control head is pointing to this position. Now in this position, the cell value is 0 is there. Okay, but this 0 is not a second occurrence of the 0. Okay, we need to find out the second occurrence of 0. So how we need to find out the second occurrence of 0 means we need to move to the left side until I will get the X symbol, because we know that we have just now we have replaced the 0 symbol with the X. Okay, so we need to move to the left side until I get the X symbol. So this I will retain as it is by moving to the left direction, and again the control head is pointing to this position. Again I will move to the left direction only. Now in the control head is pointing to in this position. Now we observe the cell symbol X is there. So this indicates that this is the first occurrence of the 0. This indicates, okay, in the next cell we have the second occurrence of 0. So symbol cell cell symbol X, I will retain X as it is. Now I will move to the right direction. Now if I move to the right direction, the control limit is pointed to this position, and by using this transition we came to know that we got the second occurrence of the 0. Okay, now what I will do, that 0 I will take, I will update that 0 with the X, and then I will move to the right direction. So this transition already I have written in this here. Now I will update that 0 with the X. Now once I got the second occurrence of 0, the next task is we need to find out the second occurrence of the 1. Okay, so in order to find out the second occurrence of 1, control it is pointed to here. Now here the position R is there. Now I will move to the next cell. In the next cell 0 is there. Okay, now this will retain as it is by performing this transition. Next I will move to the R is there. I will move to the next position. Here observe the symbol on the cell. So in the symbol Y is there. Now for the symbol Y, I will retain Y as it is, then I will move to the right direction. Okay, when I move to the right direction, now the control it is pointing to this position. So this and then observe the cell symbol. So 1 is there. So 1 indicates that we got the second occurrence of 1. For that what I will do, I should update that 1 with the Y, and then again I move to the left side in order to find out is there any third occurrence of 0 is there. Okay, so I have updated that 1, cell symbol 1 is there, I updated with the Y, and then I move to the left direction. Okay, now for the first occurrence, first Y we have replaced, and the second occurrence of 0, second occurrence of Y we have replaced. Now we need to find out is there any third occurrence of 0. For that what we need to do, we need to move to the left direction. Now the control head is pointed to this position. Here the symbol Y is there. Okay, Y. And then what we need to do, Y should be written as it is. Now we need to move to the left direction. We need to find out whether third occurrence of 0 is there or not. So left direction. Now the control lead is pointing to here. Okay. Now what is there? 0 is there. But 0 is there. So this indicates one more 0 is there. But we need to find out whether it is a third occurrence of 0. So you know that how to find out that. We need to keep on moving to the left side until I will get the X symbol. Okay. Now 0, 0, 0 written as it is, move to the left direction. 0, 0 as it is, move to the left direction. When you move to the left direction, the control is pointing to this position where the symbol X is there. So this indicates that okay, the next symbol on the cell 0 will be there. So this X will be retained as it is, move to the right direction, and then move to the right direction, then 0 will be there. That 0, now we need to operate that 0 with the X. So that we have done with this transition. Okay, now move to the right direction. Now Y is there. So Y retain as it is, move to the left direction. So that we have done in this one. And again Y is there and retain as it is and move to the left direction. Move to the right direction. Y to the right direction. When you move to the right direction, here one more symbol is there on the cell, that is 1. This indicates third occurrence of the 1. For that what we need to do? We need to update 1 with the Y and move to the right direction. 1, 1. Okay, the symbol 1 is there, and we need to update with the Y, and then we move to the right direction. 1, we need to update with the Y and move to the right direction. Yeah, correct. Next, when we move to the right direction, observe the symbol. So what is it? The B is there. Okay, B indicates the blank space. Okay. So whenever the blank space comes on the cell, this indicates that we have reached the end of the string. So whenever the symbol blank space is there, we need to retain that blank space as it is and move to the left direction. Indicates left indicates that so we have reached the end of the string. So this indicates the final state. Okay, so these are the way of solving the problem by using the Turing machine concepts. Now by using this, let me write the transition diagram. Q0 state is the, you know that it is an initial state, start. Okay, and you know that we will go to the state Q1. When the input symbol is 0, what we need to? We need to update that with the X and we need to move to the right direction. Okay, and now we have reached the state Q1. In the Q1, okay, we need to search for the first occurrence of the 1. Until that, if it is 0, we retain that 0 as it is and we move to the right direction, and for y, and y should be retained as it is, and then we move to the right direction. And all these transition I already explained. Okay, just you observe all these transition. Now, in the Q1 state, suppose if we got the symbol 1, that 1 should be updated with the y, and then we move to the left direction. So, in order to find out the second occurrence of 0, we move to the left direction. Okay, when move to the left direction, if any number of zeros comes, we need to retain as it is, and again we move to the left direction. And for y and y, we move to the left direction. Okay, now, so once all these things will be replaced, again we have to go back to the Q0, okay, for x and the right side. Okay, so observe that when we have performed the x comma xr, in order to find out the second occurrence of 0. So second occurrence of 0 means again you have to come back to the Q0 only. Okay, and then this will be repeated, okay, until for all zeros and the all ones. Okay, now after this, so we will go to the state Q3 for y, and we need to retain y and r. So that the last transition. Okay, input symbol y, and for we will retain y as it is, and we will keep on moving to the right direction, and for all y we retain as it is and move to the right direction until we get a blank symbol. Once we got the blank symbol, we will retain that blank symbol as it is, and then we will move to the okay, right direction, and this indicates that again we got the blank symbol only, where we have reached the final state. Okay, and so this is a transition diagram for the given language, and then we know that there is a two final state, one is accept state and another is a reject state. So double circle indicates the final state, here Q4 is a final state, and the remaining non-transitions will belong to the reject state. Okay, because see here in the state Q1 for the input symbol x we don't have the transition. This indicates that this whenever for the input symbol x for the state Q1, it will reach to the reject state. Okay, so since the transition is not there, so this transition diagram is a non-deterministic Turing machine. Okay, and again by using this transition diagram you can write the transition table. So transition, the input symbols are 0, 1, x, y and the blank space. Okay, and here how many states are there? Q0, Q1, Q2, Q3, Q4. Okay, so Q0 on input 0. Okay, so we have reached the state Q1, and then we have changed that into the x, and then we move to the right direction. So like that, from the Q0 only for the input 0 is there, the remaining and all nil. Now we are at the state Q1. In the state Q1 for the input 0, so we are remaining the state Q1, and we retain 0 as it is, again we move to the right direction. For the input symbol 1, we have reached the state Q2, and we have changed that 1 to the y, and we move to the left direction. And for the x, so for the x there is no transition, again for the y, so state Q1, and we retain as it is, and again we move to the right direction. And for the blank space for the Q1, so the transition is not there. Again for the Q2, so in the Q2 0yx, so 0yx means there is no transition for the 1 and there is no transition for the b. So okay, for the Q2 of 0, so remains in the same state Q2 0, move to the left direction. And for x, Q0 x right side, Q0 x right side. And for the y, Q2 y will retain as it is and left side. And again Q3, so in the Q3, and again for the Q0 y transition is there, Q0 y transition is there, so it is going to state Q3, and then change to y and move to the right direction. So in the Q3, so for y and b is there, for y and b, so remaining and all nil. For y, same state Q3, y move to the right direction. And for the blank space, move to the state Q4, blank and right side. And Q4 is no transition. This indicates that Q4 is a final state, so star, and Q0 is the initial state. So this is a transition table for the corresponding transition diagram, and this is the Turing machine in the form of the transition diagram for the language 0 to the power of n, 1 to the power of n.